Good evening, my dear student. Myself, Dr. Apil Sir. Here, I am going to say about the system of linear equation. So, guys, what is a linear equation? So, linear equation is an equation in which the highest power of the variables is 1. Yes, for example, suppose this one, ax by plus cz equal to 0. Linear equation. Yes, so if we consider or if we take 2 or 3 more this type of linear equation, then simply we call the system of linear equation. Yes, that means system of linear equation will be the just collection of 2 or 3 linear equations. Yes, so this is the standard form of a system of linear equation. Here I consider here m number of equations. How many equations? M equations we consider here, and number of variables are here n variables. You see here I consider x1, x2, x3 up to xn. That means n number of variables or unknowns I consider. And how many equations are there? M number of equations, because you see here the coefficient of x1 कितना है 1 1, coefficient of इसमें कितना है 2 1 है, then next क्या होगा 3 1 4 1 up to कितना तक है m1 तक है. That means देखो सेकेंड इक्वेशन में 2 1 है, थर्ड में 3 1 रहेगा, तो ऐसे करके लास्ट में कितना है m1. That means there are how many equations are there? M equation. And number of unknowns or number of variables are here n unknowns. Yes, this system of linear equation we can easily represent by using matrix, and also we can solve this system of linear equation by using determinant. Yes, so these are nothing, just here the application of determinants. So basically this class will be on the basis of the application of determinant, and here basically we'll discuss about the some important properties of the system of linear equation. Here we'll discuss when the system of linear equation equals consistent or inconsistent, and under which condition the system will exist unique solution, infinite solution, or will not exist any solution. Okay, so this is just you remember this is the standard form of a system of linear equation. And if we want to represent this system of linear equation in matrix form, so this will be the matrix representation of this system of linear equation. Here you see just I construct a matrix by using the coefficient of the variables or unknown. This is the matrix for the unknowns x, matrix for the constant term. Here you see these all are kya hai? Just the coefficient on the unknowns. Here you see a11, a12, a13, a1, and these are the unknowns for the first equation, a11, a12, a13. Yes, these are the coefficient of the unknowns of the first equation. And then similarly these are nothing, the coefficient of the second equation. Yes, similarly here we consider. And also you see if we take the multiple of these two matrix, we can easily find that system of linear equation. You see here how we can find that, or how we can obtain this from this matrix representation to the system of linear equation. You see here, just if you take the product of this matrix and this matrix, then this row will product this one. So if you take the product of this one, then what we get here, a11 into x. Yes, a11 into x will be here, a12 will be this x2 product with x2, then a13 here will be x3. Yes, that means we will get here x3 and so on, and the last one will be here a1 on x to the power m. Yes, this one, and this type of matrix will be there, and this is equal to this matrix. Yes, then if we take the equality, or if we use the equality property of two matrices, then this first element will be equal to p1. So from here you will get this p1. That means this way we can easily find the equation. All the equation we can obtain by using this matrix product. Okay, So this is nothing, simply the matrix representation of this system of linear equation, guys. And this matrix here A, this is X, this is B. That means this system also we can write that this way, Ax equal to B. And here this A is nothing, the matrix for coefficient, X is the matrix for unknown, and B is the matrix for the constant term. Yes, so you must remember this format. Okay, Ax equal to B. Now since you see this is a system of linear equation, now if this system or if this matrix, that means this B matrix, if this B matrix is non-zero, yes guys, you remember, if this B matrix is non-zero, then this system is called here non-homogeneous, or if this B is 0, then we call the system is homogeneous. That means you see, if all the BI's are 0, if we consider all the these BI's are 0, then means this B will be 0 matrix, then we call here this system is nothing, homogeneous. Or if some of these BI's are non-zero, that means this B matrix is non-zero, then what happened, then what we call here, this system is called here non-homogeneous. So you remember this thing. Yes, so these are the some condition. Yes, if B is not equal to 0, then one is called non-homogeneous. If B equal to 0, then this system is called homogeneous. So you remember this thing. Now you see a consistent or inconsistent. So guys, when a system is called consistent, so if a system of linear equation has solution, yes, then the system is called consistent. Or if a system has no solution, then simply the system is called inconsistent. So now guys, you see there are two type of solutions are possible here. One will be either unique solution, another will be infinite solution. So maybe the system will have unique solution or infinite solution, but in the both cases we consider system is consistent. Or if the system does not has any solution, then you call the system is nothing, inconsistent. So you remember these two conditions. Yes, now you see when the system of linear equations will exist solution, or if the solution exists, under which condition the system will be, the system has a unique solution or infinite solution. These are most important. So you see, this is the first condition here. If determinant of A is non-zero, if determinant of the coefficient matrix is non-zero, then the system is called consistent and it will has unique solution. Yes, or another condition you see here, if determinant of A equal to 0, suppose determinant of A equal to 0 and this value is non-zero matrix, that means the product of this adjoint matrix with the product of this B matrix. B means here guys, you remember B means the constant matrix. If you product these two matrix and if you get a 0 matrix, this is not 0 guys, this is 0 matrix, then the matrix is called here consistent. That means the matrix will exist solution, but that solution will be infinite solution. How many solution will be exist here? Infinite solution will exist, and in this case the system will be here consistent. So you remember this formula also, or this condition also. Or if determinant of A is 0, but this is non-zero matrix, that means the product of adjoint matrix as well as B matrix is not equal to the 0 matrix, then we call here the system is inconsistent, and in this case no solution will exist. Yes, in this case no solution will exist. Yes, so if I consider a system, suppose here you see 2x plus 3y, x plus y equal to suppose 8 here is made 2 here. So suppose this is our system. So here what will be A guys? So A will be the constant matrix. So 1 on, just you take the coefficient of all these variables. And what will be x here? X will be x comma y, and what will be b here, guys? B will be 7 by 2. Yes, so this will be x, this is x, this is a, this is b. Now you see what is the value of this determinant. So what will be the value of this determinant? 2 3 1 on. So if just you take the multiplication with this one and this one, so 2 into 1 2, 3 into 3 3, that means this will be -1, and this is not equal to 0. And since this determinant is not equal to 0, that means this system, yes, this system will be consistent, and if you solve this system, then you will get only one solution. That means that solution will be unique here. Yes, so this way we can easily verify whether the given system is consistent, or how many solution at least will exist for this system, or the system is inconsistent or not. Yes, so hope all of you can verify this type of, and another property is also there, by which also we can easily verify whether the system is consistent or not, or whether the system has unique solution or not, by using rank of the matrix. Yes, so here you see already I have discussed about this thing. Here you see, suppose ax equal to b is our here, ax is equal to b is our here system of linear equation, and then this matrix A, this matrix is called argumented matrix. Already we discussed about this thing. Yes, now if this is happen, if rank of A, rank of this argumented matrix, if these two are equal, if these two are equal, then the system will be consistent. You remember this thing, then this system will be consistent. And also if these two are equal, number of unknown, that means the number of unknowns of the system mein jitna hai, if this is happened, if these three are equal, then we call the system is consistent, okay, and as well as it has unique solution. Yes, if these three are equal. But you see, suppose if these two are equal, yes, if these two are equal, this rank of A and the rank of the argumented matrix are equal, and this is less than the number of unknown, then the system will consist or exist infinite number of solutions. Yes, system will has infinite number of solutions. So you remember this thing. Yes, if rank of A and rank of argumented matrix are equal, but which is less than the number of unknowns, then the system will exist or consistent, as well as solution will be exist, but number of solution will be infinite. And the last concept is this one, last properties, if this is not equal to 0, rank of A is not equal to the rank of the argumented matrix, then the system will be inconsistent and it has no solution. Yes, since the system is inconsistent, that means definitely यहाँ में कोई solution नहीं रहेगा. So these are the another method or another properties by which we can easily verify whether the given system has unique solution or infinite solution or consistent or inconsistency. Okay, so